Good afternoon, everyone. Now, this is a similar question to the one we have solved in class today. Now, I would like to give it a go. Now, let me. Alright. Now, a current of. Oh no, that's the second one. Let's do the first one first. Now, a current of 16 coulomb passes through the filament of a car headlamp bulb in 5 seconds. How many electrons passed and what is the current? Now, let's do the how many electrons passed first. Now, we know that the current is the charge. Is indeed the charge is 16 coulombs, and the time it took to pass it 5 seconds. Now the first one first. Question A is asking the number of electrons, and question B is asking the current. Now, this is, as we all now know, how we solve problem questions. First, we write down what is given, which in this case is this one and that one, what is given, and then we write down what is being asked. So what are they asking? And in this case, these are being asked. So, and then we find the relation to find what is being asked by using what is provided to us. So in this case, to answer A, we then go back to our nice little relation of if 1 coulomb means 6.2 times 10 to the power 18 electrons. How many electrons, number of electrons are there or will make 16 coulombs? Alright? And then we do cross multiplication. This gives me my x as 16 times 6.2 times 10 to the power 18. So how many electrons? Since we put how many electrons here, so the electrons will cancel, coulombs will cancel, so I will have nice letters, nice number of, let me ask my calculator. So 6.2 times 16, indeed. So then x then will be 99.2 times 10 to the power 18, or 9.92 10 to the power 19 electrons. Then I ask myself the question, does it make sense? Now, as I can see that the number of electrons are more than the number of electrons for 1 coulomb, which makes sense because 16 coulomb is more than 1 coulomb. So the number of electrons in this case is much more than the number of electrons corresponding to 1 coulomb. So this is crucial that whenever you get your answer, before you write it down to the little box provided for each question, you ask yourself the question, alright, does it make sense? And in this case, it does. So it looks like I came up with the answer for A. So that's completed. And for B part now, which is independent of A in this case, because I'm not going to use any any information I ended up in A part of the question, so I can easily do for B part first. But nevertheless, for B part, the relation I'm looking for provided, being asked, and the relation to connect current with the charge and time obviously is our nice little formula of I equals Q divided by time. So that then will give me, since Q is 16 coulombs and time is 5 seconds, so that will give you 16 divided by 5, which will be 3.2 amp, and that will be the answer for the B part. Alright, so if we are to highlight the answers, this will be the answer for A, and this will be the answer for B. It would be better if we don't write E here, because the question is asking the number of electrons, how many electrons, so that many electrons without any unit. E can be confusing there. But for the second part, we have to write 3.2A, because the question is what is current, so it is implied that I include its current. Second question is about similar relations, but this time current is provided, time is provided, and the question is how much charge and how many electrons have passed. Now again, let's write down what is provided. Now first of all, I am provided with current, which is 200 milliamp, as well as the time, which is 2 minutes. Alright, and the question is how much charge, so that is Q, and how many electrons, and that is the number of electrons. So is the question. So the question is what's the charge and what's the number of electrons. So this is provided to me, and I'm supposed to find these two by using whatever is provided to me, obviously by selecting the right relation. Now to answer the first part, how much charge part, the Q section, what I do is obviously I relate quickly to the relation I equals Q over time. I can rearrange this formula. There is a 1 here, as you know, and if I do cross multiplication, I end up with Q1Q is equal to I times T, or in other words, Q equals I times T, the time, and that simply will give me I is 200 and time is 2, so that will give me 400 coulombs. Beautiful, is it? I can hear some of you not being happy with that, because I didn't care much about the units. So obviously numerically the answer is close, but not exact, because I forget to change them into proper units. So instead of 200, which is milliamp, and 2 minutes, these are not the units that I can put in my formula. So milliamps need to be converted into amps, which then will be 200. And instead of milli, I can put 10 to the power minus 3 amp. And 2 minutes is equal to 2 times 60 seconds. So actually, instead of just applying whatever is provided to me, I must say the current simply is 200 times 10 to the power minus 3 times 2 times 60. So that will give me 60. This will be 120 times 200 will be 240. 240, another 0 times 10 to the power minus 3, and that will give me 24 clumps. Now I am happy with that, or 2.4 times 10 to the power 1. So that's the answer for the first part. Now the solution for number of electrons, since I know the charge, which is 24 coulombs, now I can apply my other relation to find the number of electrons, which was 1 coulomb corresponds to 6.2 times 10 to the power 18 electrons. And what about 24 coulombs? How many electrons, or x many electrons are there? That's the relation I am going to use, and I do the cross multiplication, which then provides me x is equal to, as I can see, the e's will go and the coulombs will go, and I'm going to end up with a nice letter only. So 24 times 6.2 times 10 to the power 18, and that is, my friends, 24 times 6.2 is 148.8 times 10 to the power 18. Let's stick to the two significant figures, so that will give you 1.5 times 10 to the power 20, so that will be 10 to the power 20. So that will be the answer. So if I am to circle the answer for the second part, it will be, the number of electrons will be 1.5 times 10 to the power 20, and the charge will be 24 coulombs. Thank you for listening to me.